Hey guys, sorry to be out today. Me and Miss Harding are on a field trip in Atlanta. If you would, go ahead and add these two definitions to your vocab in your Unit 4, page 1 definitions. We're going to talk about the line of best fit today. So if we're comparing two sets of data, two variables, we want to be able to create a line that matches that data the best. It's not perfectly linear, but we want to create a line that would model that relationship. So as you see, it says a straight line that best represents the data, and basically that line falls in the middle of all of those points. So if you had a scatter plot that looks something like this, and your line of best fit would go through as many points as possible, keeping the same number roughly on top and on bottom, basically trying to find the average if you were to take all those points and make them linear. So what we're going to do today is our goal is to be able to find the line of best fit, and we're going to use a technology tool called ShowDoor to do that. Now, when you type in your coordinate pairs, it's not only going to give you the line of best fit, it's also going to tell you how strong or weak or positive or negative that relationship is, and we call that vocabulary term the correlation coefficient. So if you will jot this down also in your notebook, two definitions today. We're going to find the line of best fit using technology. It's also going to give us the correlation coefficient. You'll see this as R equals some value. And this value can be between -1 and +1. So if it's a really, really strong negative relationship, in fact, if it's perfectly linear, the scatter plot would look like this. It is that's positive. Sorry, we're on the negative side. It would be a perfect linear negative relationship. That would be an R value of -1. Now, it can still be negative, but maybe it's a little bit weaker. It would be more spread out like this, but the points would be generally trending down. This would be an R value of maybe 0.4. It's not so close to perfect at -1, but it is still negative, and it is a weaker correlation. Zero correlation yesterday we talked about was like the shotgun blast, where there is no relationship between these dots. It's just random. We can't actually say there's a correlation. That would be an R value of 0. Positive correlation, if it was weak, it would still form an upward balance, but these points would be pretty far spread apart, so it's not strong. Now, last but not least, a really strong R value of maybe 0.9. It would look like this. So it's really, really close together. It looks pretty linear. This may be like a 0.9. It's really close to a straight line. So R would equal 0.9. It's positive, and it's close to 100% linear. If it was a 1, it would be a perfect line. However, this one is 0.9. It's pretty close. Those points are really close together to what we would imagine when we draw that line of best fit. Now, that's our goal today, to use technology to draw the line of best fit. To get the line of best fit, the equation for it, and then also to read the correlation coefficient R. So let's look at an example. All right, here we have the relationship we're trying to figure out between fat grams and calories. So we took a couple just fast food restaurants, and we calculated the fat per these sandwiches and then their total calories. And we want to know, is there a relationship between the grams of fat in a sandwich and the total amount of calories that you're going to end up eating? So in order to do this, we are going to use this link, showdoor.org. It's actually linked in Google Classroom after this video. If you would open that link, you're going to see that you're going to see this picture. Now, the first thing is we need to type in our coordinates from that table. I'll bring it up in just a second into this box down here. Once you type in your coordinates, separating the x and the y value with a comma, you're going to click Update Plot. Once you update your plot, you'll see these points show up on your graph. Of course, it's updated. And then last but not least, you're going to click this display line of best fit. So let's go back to that data. All right, our first coordinate pair is 9, 26. So I'm going to use our show door link. Ba-ba-da-ba. All right, so from show door, I'm going to type in that coordinate pair. First one was 9 grams of fat, had 260 calories. Then 13 grams of fat had 320 calories. 21 grams of fat had 420 calories. 30 grams of fat had 530 calories. 31 grams of fat had 560, which there's also another sandwich that also had 31 grams of fat, but this one had 550 calories. Maybe it had lettuce instead of or a whole wheat bun, 10 calories less. And then 590 calories. And I haven't put in all of my data. I'm going to let you actually type all of this in. But then I click Update Plot. So this button right down here, once you type in your data points, notice that it does display the line of best fit. The red line is going through most of these dots, so this is a strong correlation. Last but not least, you would want to click, whoops, I already did, ruin the secret for you, display line of best fit. So notice here, it gives me y equals mx plus b. This right here is my line of best fit. So this is super important. It's going to calculate this line of best fit for me. It also gives me my correlation coefficient. So is this a positive or a negative correlation? Well, the graph obviously is increasing. As you eat more fat, your calories are going up. So this is a positive correlation. You also notice that 0.99 is positive. That's a little hint there. And it's also a strong correlation because anything greater than 0.5 is considered strong. The closer you get to 1, the stronger it is. Notice 0.999 is really close to 1%, which would be a perfect line. So this is a strong positive correlation, meaning that the more fat you eat, or the more fat grams a sandwich has, the more calories there are. Last but not least, we need to interpret what the slope and the y-intercept mean. Now, let's talk about the y-intercept first. That is where the x-axis is 0. Remember, x was grams of fat. Okay, so 145 is the starting calories. So 145 is the starting number of calories at 0 grams of fat. Remember, your y-intercept is where x is 0. So at 0 fat grams, this is a really healthy sandwich. The sandwich would have 145 calories. All right, so your y-intercept is always whatever that constant is that they're adding at the end, and go back to what x and y represent. In this example, it was grams of fat and calories. Your y-intercept is where x is 0. So at 0 grams of fat, the sandwich had 145 roughly calories. Let's talk about the slope now. Now, the rate of change, the slope, is roughly 13/1. And remember that our rate of change is the change in y over x. Well, what did y represent? Y was the calories. X is the fat grams. So what this is saying is for every 1 gram of fat, it's a positive 13. So you add or you increase 13 calories for each gram of fat that you consume. So if you're trying to be health conscious at the restaurant and you know one sandwich has more grams of fat, you can already plan that you're going to have to burn 13 more calories based on that 1 gram of fat. Now, 13 is actually not the y-intercept, or sorry, the slope, and 145 is not the y-intercept. I did not type in all of the data points. Right now, I would really like for you to go back to our original slides. Let's close this. All right, and I want you to type in all of these data points into ShowDoor. Remember that it is linked in Google Classroom. You're going to type in all of these with a comma in between each one of them. And then find your line of best fit. And then think about what that means in context. Right now, if you would pause and work on that, please. Talk to your neighbor just to make sure that you type them in. Be careful not to click on the graph. All right, for your work period, last but not least, here are two problems that I want you to graph and show door. Write down the write down the line of best fit. Tell me about the correlation. Is it strong, positive, weak, negative? Then tell me what the slope and y-intercept mean in context. The sum will collect this at the end of the period. So take your time, type these into show door, and answer questions 1 through 4 on each of the examples. Best of luck. I look forward to reading your answers, and I will see you tomorrow. Bye, guys.